titled Everything Sucks.
Yes. All right. So I work here at Intersection. And how I've been feeling about transit the last few years is status quo. Everything sucks. So that's the beginning of the slide. So how bad is it out there is what I'm going to try to address in the first part of my talk. Oh, I should start a timer. Do that. Okay. So I'm a bicyclist. I bike everywhere. Bike lanes are always blocked. How can I help? That's how I started. And the first shot I had was by suing UPS because I noticed that they were always in the bike lane and they have very definitive brown trucks, so I thought that should be easy. So I tried suing them in small claims court and I lost. And then I tried suing them again in a different court and I lost that one also. I'm still suing them actually, but that's unrelated to this talk. And the judge said to me, can you prove that UPS is an extraordinary blocker of bike lanes? And I thought, I don't know. And so then I remembered that NYC DOT has all these cameras up, which I don't know if you guys know that, but they do. And you can go to this website, whose URL recently changed, and you can click, and it gives you a 1-second snapshot, very low quality, of the streets of New York City. And so I knew that was out there. And so then I knew that I had a computer. And I thought, bring them together. And so I downloaded about a week's worth of data from one of the cameras near my house, my apartment. And by download, I mean I just inspected, found out the IP address, and then just sat there polling on the computer, downloading every image. And then I went through and annotated 2,000 of them by hand. So that took a while. And so you would click on each individual thing and say what it is. And so then I took TensorFlow, which is Google's machine learning framework, and I put all my annotated images in, and I retrained this available model zoo, which is the ResNet 50 one. And I could get it to kind of annotate, this is a 10-hour-long YouTube video, and it kind of annotates the city street. So we're getting close. So you can click around. Oh, that's not right. And then, how do I go to the next? Okay. Then the question was, is the bike lane or bus stop blocked? So what I did here, and this is needs future work, is this camera move, but luckily the DOT didn't move it and doesn't seem to move it a lot. So this was facing just here. And so you can see green is bike lanes, red are police vehicles parked on a sidewalk, blue is a bus stop filled with vans. So what the code did was it just went through and it has an understanding hard-coded of what those different regions are in terms of pixel space, and then said if it's a car and it's in this thing, that's not good. Car and bike lane. To bring up the obvious point, to expand this further would require more effort, because if the camera moves, that whole thing is broken. And if you want to expand this to other cities, other cameras, etc., we need an automated way of understanding where bike lanes are and bus stops. So that I will come back to later. So that was this piece. So how bad is it? So see from my data on this one Harlem block, but I will make a wild assumption and say this is representative of all of New York. Seems like maybe. 55% of the time the bus stop was blocked. You can read it. 40% bike lane blocked. 55% 7 a.m. So it's pretty much always blocked. It's pretty much blocked. As I knew going into this. Okay. And so then I do some graphs about time of day and how it's blocked. So you can see bike lanes at 3 a.m. Not as many people are biking, nor are they driving. Not blocked. But then when you need them most, blocked. So that was that piece. The next piece that I thought you guys would find interesting is how could I get some publicity for this? Because you saw via my other things, I like the publicity. It's reaffirming. Nice to see. So people ask me that you must know someone there, right? That seems difficult. How do you get in the New York Times? It actually was very easy and very hard. Similar to the, what is a bicycle? What is a car? I just emailed lots of people at the New York Times on LinkedIn. I took their name and then just did like dat at New York Times. And so I got a lot of like bounce backs, but one to someone named Brian, who I had never met. I have been doing a deeper investigation using and DOT cameras. I wrote it up here. It's not public. And then he just responded, yeah, forwarding to this person. So I don't know if that's how it always goes, but so far that's what I do. I just spend like a few hours emailing everyone on LinkedIn, and then sometimes people respond. So that was the article, and that's me. Okay, so what's next? So, oh, I forgot, I just blew it. So then I started working at Intersection, and I had the issue with the whole cameras when they move, and so I didn't forget about the project, but I was thinking about other things. And then Anders, who's going to come up here in a few seconds, from Do It, City of New York City, Do It, he reached out to me and said, "Can we use this whole project for more stuff?" I was like, "Is it open repo on GitHub?" And so we started talking about how can we work together to do other things related to that. So, demo. So we have all these cameras. So what I've been working on is writing a program such that first thing we want to do is we want to save not just one image, but as many images as possible. So currently, I have my script running in AWS as well as on my computer, which you'll see. And it goes and it scrapes this PHP link on the DOT website, gets all the list 700 cameras, and then spins up a bunch of threads and downloads all of them. So like once a minute, it downloads now all 700 images. So we can start that going. And then the other thing this piece does is, so if I run it on my computer, as you'll see, this computer, it takes about 2 seconds per image to process. It's kind of slow. But when we run it in the cloud in Amazon, it's about 1/10 of a second, even faster. So every minute, we're now processing all of those cameras. So you got to give us time. My computer is in a kind of huff its way on. But I will go show you some ones I already did this earlier. So it goes through and it annotates all the images. So it does pedestrians and cars, and some things it gets confused by. And some cameras are pointing at the sidewalk. I don't know about that. And some things it gets confused by. So here are the ones that's going right now. So this is today at 5:28. No, that's not right. 7:53. Okay, there we go. 7:53. So that's right now. So my computer's going along and it's crunching through and getting all this data every X seconds. So if we look here, it's just printing out now how many cars and how many trucks it's seeing at each timestamp. And we're saving this right now into just a big time series database. And now, Anders, come on up. So the man who restarted this whole project. So all this is open source on GitHub, and we're churning through and creating all this data. And Anders, what are we gonna do with this?
Yeah. So first, when I found out about Alex's work, we were working on something similar, a little bit more slowly, though. I mean, I do work for the city, so no need to rush or anything. So, but we were working with DOT, which made it even more challenging. So I was thinking there's got to be a better way than this. And then somebody alerted me to Alex's excellent work, and I was pretty blown away. That was pretty cool, I thought. And so, but I was looking at it, I was like, automating ticket writing is not a good agenda in the city. You're not going to sell that to anybody. And it's not really what we were looking at it. But I mean, the basic principle of being able to actually detect and count cars is really huge. It's actually bigger than you would think. So traffic counts, just for comparison, DOT, they have I think it's 20, 22 persons employed full time just counting cars out there. And they're not going to count as many as we can do. So this is something that will be very scalable. So traffic counts in itself is really huge. Another thing is that one thing is counts, but if we can know also what kind of cars are out there, if we can know how many trucks are there, how many buses are there, how many cars are there, it's going to be very interesting for us. Because the actually the POC there, or the project that we were working on, was related to the connection between traffic and environmental health. So we wanted to understand the effect of traffic on air quality, something we were working with the health department on as well. So that was the way we got into this. But I was talking to another number of different people around the city, and there were actually a lot of other use cases that popped up. I was talking to the fire department, and for them, actually, it's a huge problem. If somebody calls in and tells there's a car crash, and they're like, "Yeah, cool. So where is it? I don't know, back there somewhere." And so yeah, they can probably see where their phone is, but they're in their car and they're already gone or something like this. So they can actually drive around for quite a while just to figure out where the actual crash is. It will take a while sometimes. So this is why they were very interested in somehow getting information on where that particular car crash could be. Another thing is that you can actually also help them because they do have an information system where you can input information into it. So traffic anomalies would be interesting for the fire department, for 911, and anybody else, which would be really cool. You can see that something is happening here. So what is it? I mean, we could raise an alert on this. Pedestrian counts is huge in cities. You want to know where pedestrians are because pedestrians, they usually have credit cards, right? So you want to understand the flow of traffic of pedestrians and money and so on, and the list goes on. Traffic jam prediction. When you understand the flow of traffic, you can kind of understand and build models for how queues are building up and give warnings for it. Air quality, as I told you about, floodings is actually another thing. So this is where we move to the next level, and why I'm saying that traffic cameras in general are a huge untapped resource, because it's huge also for the city to understand where there are actual floodings in the street. We don't know today, and nobody knows. And they were approaching me because they wanted to know how to use social media for it, and I was like, maybe we could train this system to detect floodings. Snow clearance is one of the biggest things in the winter, of course, naturally on 311, that my street hasn't been cleared and so on. But if we can find out and find patterns and optimize that, it will also be huge. So this is just a small list of things that we were starting to think about as extension of this. And this is our new innovation lab, because we just built this new lab and we want to start to engage with people like you. This is why I'm excited to be here, and I was really blown away by all this. And just full disclosure, I used to live in Princeton, so I was very moved by that first presentation. I'm really happy somebody's thinking about it, but I moved here recently, so now I have only 30 seconds to work, so it's a lot better than 2-3 hours. So this is the venue that we hope to engage other people, and maybe even this meetup at some point if that becomes relevant. Thank you.
All right. Yeah. So we're putting the all the data publicly, of course, and so we'll open also for ideas of visualizing it. Kaggle sounds cool. I don't know what that is, but looked it up. So we want to figure out ways of giving people the data and using it. How much time do I got, Cozy? 1 minute? Oh, I also have some unrelated crazy ideas that I thought I'd share. Okay. One, what if the MTA app, what if there's some MTA app where you would just pay people and then they could take pictures of people blocking bus lanes and then you would pay the person? What if the subway doors were just covered in honey or some viscous, sticky, smelly fluid, and that way you wouldn't want to touch the door or block the door? And maybe just take out like an insurance policy, so then if it crashes, so we run the trains faster and maybe they crash more, but then the insurance pays. I don't know. Anyway, that was me, and you can check out the GitHub at intersection R camera. And we're going to put all the data up there and other places. And we look forward to ideas about how we can visualize it and make it interesting. And that's it. Let's see how the... Oh, one question. Don't be too excited. Yes. Great question. UPS. Okay, so... Oh, did you actually prove that UPS is an extraordinary violator of bike lanes? According to the judge, I have not proven it. However, I do have the model, and it is trying to detect UPS trucks, which, because they're big and brown, it's doing an okay job at, which is great. But at night, it doesn't do so well because we lose the image color. And so I'm still working on it. Basically, still working on it. Jury's still out in more ways than one. And I hope one day to successfully sue them. So that's the answer there.
Thank you, Alex.